All right, this video is all about dealing with ratios with graphics. So hopefully you've already watched the age dependency ratio because this first graphic deals with age dependencies in a graph. So look at your horizontal axis. Remember that horizontal goes this way. So here we're talking about years from 1950 to 2080. So you'll notice that this part is all projections. So this graph was made in approximately 2006 or 2005. So everything else is projections after that point. What about the vertical axis? Well, here's our vertical axis. Notice that it says per 100 persons. So the vertical axis actually represents the the dependency ratio. So let's just pretend like we're talking about this. That spot looks to be maybe around 12. That's 12 out of 100. So that dot is old people. So 12 old people are dependent on every 100 workers. That's what the vertical axis represents in this problem. The child dependency is not the same as what was calculated on the previous page. So the previous page calculation for child dependency, if I talk slow enough, I'll find it. 304. Okay, on the previous page, our child dependency was 0.304. All right, 304 thousandths. So child dependency here, children is the solid. It appears if we're talking about, when we're at, if you look over, it's closer to 45 over 100, which would be 0.45. So why are those not the same? Well, my personal opinion, we're talking about estimates. So we talked about in that last video that they were estimates. These are also estimates. So because we're dealing with estimates, we might be looking at two separate data pieces. So depending on where they got their information, we used the 2011 census in the last one. Well, this was 2005. So perhaps they were using the 2000 census data or whatever else. But more than likely we were using two separate pieces of data, and that's why things were different. So there we go. All right, what is happening in the baby boomers retire time period? Well, that's from here to here. So notice what happens. Well, this spikes up, which is all dependents. This spikes up, which is old people. So the old people become dependent, right? They're all retiring. Well, if they retire, they're no longer in the working class. They're part of the old people. So the overall dependents are increasing dramatically. Look at, because the old people, now the children are kind of staying level. Those we're having babies at a constant rate, but our old people are retiring at a very quick rate. And what appears to be the long-term projection? Well, overall, the all dependents, if we look back, is over 80. Let's call it 85 over 100. That's high. That's 85 dependents for every 100 workers. I'm estimating there, obviously. But you can see here that it looks like the old people and the children are going to have about the same dependency ratio. In our last example, children were 304, old people were 191. But because the baby boomers are going to really jump that up when they finally all retire here in the next few years, and these two numbers are going to get close to being the same. That's what's going to happen in the long run. All right, let's go to the next one. And I don't have the top piece here, but the one thing that it talks about that this is an inverse dependency ratio, meaning we're talking about workers per dependent. So instead of having the dependents in the numerator, now we're going to have the dependents in the denominator and the workers in the numerator. So a ratio of 1.0 here, well, 1.0, if you 1 over 1, that means we have one worker for every one dependent. That's what a ratio of 1 means. A ratio of 2, well, put a 2 over 1. Now we have I'm conditioned. Now we have 2 workers for every 1 dependent. So this is like our old school dependency ratio. This would have a dependency ratio of 0.5. right? Because that's 1/2. If we talked about dependents over workers, just look how we flip the ratio. We put the workers on top. That's basically what this is all about. Is a higher or lower ratio more desirable? Well, when we're talking about inverse, we want higher because the top number, the numerator, represents the workers. Remember, in dependency ratios, we want low because low means that we have more workers than dependents. Well, now that our workers are in the numerator, now we want a high number because a high number represents that we have more workers than dependents, and that's what we want. So keeping that in mind, according to the graph, which region of the world had the best working age dependent ratio in the 1950s? Because, remember, so we're looking for high. Who had the highest? In this case, we want highest because it's the inverse. So 1950 is here. The highest was that. So Europe. Europe wins for the highest in the 1950s. And what about today? Well, we're roughly 2018. So this graph here, now this is the hard part on this. You've got to figure out who this belongs to. So I'm going to follow this around. It looks like this is the arrow, and that belongs to East Asia. So East Asia has the best inverse ratio today because they have the most workers per dependent. And it's roughly, I don't know, maybe 2.3. So they're at like 2.3 over 1. So 2.3 workers for every 1 dependent. You might have estimated that to be a little bit different, but that's what it means. So they have the best inverse ratio of anybody today.